Okay guys, now this ring on my finger, which you see over here, is none other than the famous C6H12O6, better known as glucose. Now you're probably wondering, why is the chemical formula for glucose C6H12O6? Well, that's quite simple, because this hexagon ring over here is made up of carbon atoms, which are 1, 2, 3, 4, 5, 6. That ticks off the 6. H12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, H12, and O6. So that means 1, 2, 3, 4, 5, 6 O's. Yep, that basically means C6H12O6. But this right here, my friends, is known as a simple sugar. Glucose is known as a simple sugar, and a simple sugar is the tiniest unit of a carbohydrate. And over here, what makes glucose special is that as a single sugar, it's known as a simple sugar. You can also call it a single sugar or saccharin. Probably don't know if I'm pronouncing that right. But then, this doesn't exist on its own, right? Because we know that every time we digest something in our digestive tract, we have sugars being broken down to this most simple, soluble compound, which is then absorbed into the bloodstream, and hence in turn provides us with energy, because that's what glucose is for. And hence the famous chemical reaction of C6H12O6 plus oxygen to give you, what does it do? Probably CO2 plus H2O. But this is mysterious. It's not broken down. Because why? This equation is not balanced, and this is why. We have 6 glucoses on this side, but then we only have 1. How do we make things right? That's quite simple. Just put a 6 over here. So when you have 6 glucoses this side, 1 glucose over here, 6 carbons, and this is now 12 oxygens, 13 oxygens. Ooh, this is gonna look messy. But let's see if the math's right. What happens if I add another 6 here? That now means I have 12 H's. That looks about right. 12H, 12H, 6 sixes, 6 C's, 12 O's, plus 6 O's means that's 18 O's. How do we set this right? We have 6 O's over here and 2 O's over there, which means we have 8 O's over here in total. What a mystery. If we have 8 O's over here, and then on this side, this is 6 times 2 is 12. 12 plus, sorry, let me just put that down. 12 plus 6 is equal to 18. How do we balance this? Well, there's only one good way I can think of, and that's to add a 5 here. Well, what is that now? 6 C6, 6 of those, H12, 12 of those, and then these become 10 plus 6. No, my math fails me. This should be a 6. Why? So that this then becomes, these are 12 plus this is 18. And then 6 times 2 is 12. 12 plus 6 is 18. 18, 18. The math is balancing. The math is mathing. But then, as with all combinations, glucose doesn't necessarily just exist on its own. There's this special thing which happens when two things are joined together and they form what we call a bond. You guessed that right, huh? So I'm going to explain why I'm emphasizing this over here. So there should be OH. I'm just going to highlight the OHs. OH, OH, and then we have what we call CH2OH. And once you get a bit more advanced in chemistry, you'll realize that this group over here is what is known as an aldehyde. But anywho, when you have two glucose molecules joining together, let me demonstrate this. So I'm just going to write this backwards. O, OH, C, the aldehyde, OH, OH. When these two combine together, so that's a simple glucose sugar, a single sugar, plus another glucose, we get what is known as a disaccharide, better known as a double sugar. But to be specific, over here what you get is a chemical compound known as maltose. But when this maltose forms, there is something else which is released. And that, my dear friends, is H2O. And you can guess it, that's a water molecule. So when you have the reaction between two simple sugars, you end up losing an H2O. Because what happens is that these guys, these two H's and these O's, they condense. And once these disappear, it forms what we call a glycosidic bond. And in this reaction, H2O, which is this guy, is lost in the balance. So this right here is the closest step to polymerization. And if you're interested in that, let me know and I'll explain it further. Oh, and by the way, a polymer is just a combination of multiple isomers. Again, really interesting. Organic chemistry is interesting. Peace out. That's it for tonight.